Hi, I'm Matt Needham, and this is my lecture on definitions based on the Uniform Mechanical Code. So these are different words that we're going to learn the definitions of and a little background on them also. So let's dive right in here first at air outside or outside air. This is the air that we're bringing into the building with the intent of improving the air quality. Buildings all need to have a certain amount of fresh air that comes into the building. Usually at least 15% of air needs to be outside air in order to freshen the building. And sometimes we'll even do 100% outside air, which we call economizer mode, which you might do, let's say, if the building's a little bit warm but it's cool outside, we can open up the dampers all the way and flush the building with outside air. Okay, so that's air outside. Let's go to air return or return air. This is the air that's in the occupied space, in the rooms or zones, that leaves to go back to our air conditioning and heating units. So this is the air that's going back in. Usually the return air grill is the biggest of the vents, much bigger than the supplier vents or where the air comes out. So this return air is going back to the unit to be conditioned. Okay, return air. What is an air handling unit? An air handling unit is something that has a fan inside, usually an air filter, and a lot of times a hot or chilled water coil, and you'll have a unit like that that is providing the air for the occupied space. So if you have a box, a unit, whether it's the size of this room or even quite a bit smaller, it can be considered an air handling unit. Now, what is not an air handling unit would be a package unit. A package unit is like what you might have on your roof in a smaller building or a residential building where all the heating and cooling and fan is all in one box on a roof. And if it has everything inside that it needs, all the heating and all the cooling and everything is right there, and the fan is inside to provide air, that wouldn't be considered an air handler or even at all. It'd just be part of a packaging. But we have a separate system, a separate metal box, if you like, that is providing the air for the building, and it may have a hot water coil, chilled water coil, air filters, or even just some means of heating that may be considered an air handling unit. Now, what is a boiler? A boiler is a closed vessel for the purpose of heating liquids, 99% of the time water or steam, okay? And that definition has been with us for a really long time. I'm not fond of the definition because within that term boiler, when you're heating water for like hot water heating boilers, which is a type of boiler, nothing's boiling. And that bothers me. But that's the standard. It's a closed vessel for heating water or steam, okay? And we're going to get involved in what is a high pressure boiler. What's the difference between a low pressure boiler and a high pressure boiler? Now, a high pressure boiler is when you heat steam itself in excess or over 15 pounds per square inch gauge steam pressure, or you're going to heat water itself to 250 degrees or greater. And by the way, water at 15 psi boils at 250, so you can kind of see that relationship. Or the third way that you have a high pressure boiler is just water, may not be 250 degrees, may not be steam, but if you pressurize that water and heat it and raise the pressure up on the water to 160 psi, in excess of 160 or over 160 psi, that would be considered a high pressure boiler. And that's where, when you have a high pressure boiler, that's where you need to have an operator, someone with a steam engineer's license, to be right there to take care of the boiler, to monitor it, because it is quite a bit more hazardous than a low pressure boiler, which is just the opposite of everything I just said. 15 psi of steam pressure and below, it's a low pressure boiler, right? If you're just heating up water to 250 degrees or below, low pressure boiler. If you're just heating water up to a pressure of 160 low pressure boiler. Okay? What is the breathing zone? What is the breathing zone? The breathing zone is inside a building, inside a conditioned space, anywhere from 3 inches off the ground to 72 inches or 6 feet high. Because that's basically where someone's mouth can be in a building. Now, if you're laying on the ground, on your side, your mouth, even the top of your mouth will be 3 inches off the ground, right? And if you're 6'3" or 6'4", your mouth will be at 6 feet high or 72 inches. Now, people over 7 feet are just out of luck. But we have this guidance. We have to have this defined to think about the breathing zone for things like fire and smoke and different things like that. So that's why we define the breathing zone 3 to 72 inches. Now, a chimney is something that gets rid of products of combustion mainly, or other fumes, taking them out of a building. Now, when you think of a chimney, you think of like a fireplace with a chimney, most certainly, and that is, you know, something we think of as very old and traditional, but also vents. We have like B vents and BW vents that take the products of combustion off heating appliances. So when we're taking something like that and getting rid of it, not just the regular air, it's either a chimney or a vent, and those two terms are fairly interchangeable, right? And then that leads us to combustion air. Okay, what is combustion air? Combustion air is all the air that a heating appliance needs, like a furnace or a hot water heater or a boiler or what have you. So that means that you first have combustion air, which is the air involved in mixing with the natural gas and for combustion, right? And mostly it's air, 90% air or so, only about 10% natural gas, we'll say, for a hot water heater or a furnace. And when you mix those two together, you need to have a source of air continuously so that you can have proper combustion. We also have, as part of combustion air, dilution air, which is air that will dilute the products of combustion when you don't have like a power venter or a combustion blower. Think of a hot water heater, how there's that little space at the top and it can draw air in along with the products of combustion going up that vent pipe or chimney pipe, right? That would be dilution air on top of your hot water heater. That air can leak in and dilute the products of combustion, mainly lowering the relative humidity. And also, just to have part of this here on combustion air is just to have some ventilation, so to dissipate heat and things around the heating appliance. Now, we're going to condensing appliance. What is a condensing appliance? Well, it's a heating appliance that is going to condense the water vapors out of the products of combustion. Okay, so these are high efficiency, like furnaces, 95% furnaces and above. Traditional furnaces that you might have in your home are like 83, 85% furnaces, and they provide a lot of nice heating, but if you touch the vent or chimney pipe, it's very hot to the touch. So you're paying for that heat, but a good percentage of it's going up out the chimney pipe, out the vent pipe, to outdoors. You're wasting that heat. A condensing furnace takes those gases and has it go through like an extra heat exchanger so that the products of combustion coming off the chimney or vent pipe are just barely warm. And in doing that, one of the main byproducts of combustion is water vapor. We condense that water vapor into liquid, right? That's why it's called a condensing appliance. And then we have to have a condensate drain that takes that liquid water, somewhat acidic, away. Now, here we have the conditioned space. Not every single area in a house or a building is conditioned all the time. Now, generally, you're going to always have heating, and you quite often will have cooling along with that. But then there's some areas like a closet. I mean, even look right here in my cave. There's a closet. Inside that closet, when the closet's closed, you know, kids can play hide and seek or whatever. It's not a conditioned space. We don't have supply air going in there, right? Underneath your sink in your kitchen, where your plumbing is and your drain pipes, etc., that's a space that's in your house, but it's not a conditioned space. So just to kind of understand, and there are certain storage areas and different places and buildings, garages, things of this nature that quite often aren't part of the conditioned space. Now, what is a damper? A damper is usually a piece of thin metal that can open or close more or less to allow more or less air flow. Okay? And you have manual dampers that you can manually turn with your hand to open it or close it. We have automatic VAV or variable air volume dampers. We have fire dampers, different dampers like that, so that we can either cut off airflow or open airflow depending on what we need. So that part that can open or close to provide more or less airflow within a duct is a damper. Okay, and then a duct is a tube for conveying moving air around, right? Generally here with chimney, it's more about getting rid of fumes, products of combustion, right? Where the ductwork is for moving around air, either getting rid of it from a building, necessarily older air, or bringing in outside air, or having return air come back, or supply air coming to a room, something like that. We use ductwork or these pipes that are very large to move the air around. Now, here's a term you may have heard: ductless mini-split system. Ductless mini-split. What is that? Well, that's an air conditioning system, usually heating and cooling, but primarily, but certainly at least cooling. And these are systems that are ductless. They don't have any ducts, okay? They usually mount right on the wall in the conditioned space. They're thin little units, and they provide heat, hot air or cold air, and they have a filter there, and they don't have any ductwork, so you don't have any losses through the ductwork. And then they have some refrigerant piping and electrical that go outside to a condensing unit that sits outside to get rid of, let's say, the heat when you're in the cooling mode. Okay, so it's a split system because it's split in half, right? The part that provides you with cool and hot air is a small little unit inside the house, and the part that gets rid of the heat, let's say when you're in the cooling mode, is split from it and sits outside the conditioned space. Okay? Ductless mini split, very popular, very energy efficient way. Now let's move over to the other side of the whiteboard at this time. Come on up here to evaporative cooler. What is an evaporative cooler? An evaporative cooler is a cooler or something that can provide cool air through the evaporation of water into that air. Okay? The slang name for this is a swamp cooler, by the way. The appropriate name is evaporative cooler. And by having water that evaporates into the air, you get some inexpensive cooling and some humid air into the space. Okay? And it works fantastic for cooling when the relative humidity is very low. You can get a lot of water that can evaporate into the air, and you can get a lot of inexpensive cooling. I've done some experiments with it. If it's dry enough outside, like 10% relative humidity or whatever, you can drop the temperature like 13 degrees going through an evaporative cooler. Okay? If it's almost raining outside, all you're going to do is move the air. That's it. Okay? And a lot of times we do also use this in restaurants just to make up air, right? Kind of like outside air, make up air, to bring in air for all the air that's being lost because we have so many exhaust fans in the bathrooms and in the kitchen and those big kitchen hoods. We have a lot of air leaving, and if air is leaving, we need to balance the air, and we generally bring that in through an evaporative cooler. And if the relative humidity is low, we might get some inexpensive cooling like back in the kitchen or something like that. Okay? And then here we come to an evaporator. An evaporator is the cold coil in an air conditioning or refrigeration system. Let me show you this diagram. So this is the refrigeration cycle right here. And the cold coil that gets cold, that we usually think of air conditioning, have air blow over this cold coil, and the air comes off cold into your conditioned space. You could almost think of this as like a window unit. That cold coil, where the refrigerant is going through and evaporating, is called the evaporator. Okay? And if you take my classes, you'll learn very in depth about the refrigeration cycle going around the system here. Okay, but that's the evaporator, the cold coil that provides the cooling in an air conditioning or refrigeration system, and the refrigerant is boiling off or evaporating inside the piping here in this cold evaporator. Okay? And one thing you'll learn from me is that boiling doesn't mean hot. All right, let's move on to a heat pump. A heat pump is a special kind of air conditioning system, not refrigeration, air conditioning system that causes the refrigerant to flow in the opposite direction. So just once again, in the normal cooling mode, the refrigerant flows around this way, okay? And we pick up the heat inside the building here. We intensify it in the compressor, and we dump it usually like outside on that outdoor coil here at the condenser. Okay, and the refrigerant goes in this direction. The heat pump has a special valve in it that causes the refrigerant to go in the opposite direction, so that even if it's cool outside, there's some heat energy. We take that heat from outside, we intensify it here, and then we blow it inside like in the winter, and the refrigerant goes this way. So a heat pump is an air conditioning system that can have the refrigerant flow in the cooling cycle and also in the heating cycle. Heat pump. Okay, the high side of the system, generally when we're talking about it, and let's just think again about the refrigeration cycle here, the high side of the system on this chart is everything in red. Okay, so here's the compressor. The refrigerant flows this way down the discharge line, the condenser, the liquid line, and this is called the high side because the compressor is compressing or pumping up the pressure. So this is the high pressure side of the system. And while we're at it, I'm going to skip ahead a little bit and go over a definition that's coming up. The low side of the system is the blue here, where the refrigerant is evaporating and absorbing heat as it goes through the evaporator and then coming on the suction line, which is part of the low side, and the compressor is sucking it from the suction line, so it's dropping the pressure here lower. So this is the low side of the system, this is the high side. And I'll just run through the refrigeration cycle for cooling really quickly since we have so many definitions that deal with it now. The refrigerant enters the evaporator as a low pressure, low temperature liquid with a little bit of vapor. As it travels through the evaporator, it absorbs the heat from whatever we're trying to cool down and turns into a vapor. The compressor sucks this vapor and squeezes those molecules into a smaller pipe, and the pressure and the temperature goes up because these vapor molecules are compressed into a smaller area. So we've picked up the heat here, we've intensified it here, and then we send it to, let's say, that outdoor coil. Think of like this being the front of your window unit and this being the back end of your window unit that sticks outside. And as you go through here, the refrigerant gives off its heat outside here, and it condenses into a liquid. And once it totally condenses into a liquid, it goes into a metering device where it's metered down. It goes through a tiny orifice. We've already gotten the heat off of it, and it drops the pressure and the temperature and it keeps going around again. Quick one time. If you're taking my other classes or whatever, certainly we go over this quite a bit more. Now, let's jump over here to hood. That's where I live. No, I'm kidding. Okay, well, okay, so a hood is the large opening above cooking appliances or dishwashers or steamers that is there to remove those fumes or vapors from the occupied space, like usually the kitchen area. You'll see a big hood like this up high, and then it goes into a smaller duct, right? A vent, actually, going out, okay? And so that big opening over our cooking appliances and things like dishwashers too, where all those fumes and vapors, products of combustion, are sucked, that's called a hood. Joint, braised. Braising is melting alloy over 840 degrees Fahrenheit. Okay, now braising is this. You'll have two pieces of metal that you want to join together, and then you are going to melt another metal into where it's joined together. And if that alloy or metal melts at a temperature above 840 degrees, you're braising. Okay? If it melts at 840 degrees or below, you're soldering. So this is a soldered joint, okay? And just so you understand what is the difference between braising and welding, welding is this. You have two pieces of metal you're trying to join together, and as you go, let's say this is the metal, as you go to add your filler metal here to the base plates, you're going to actually melt some of the metal that you're working on and then add some of that alloy to it. So you're actually, with actual welding, you're melting what you're working on and adding an alloy. With braising or soldering, you're not melting what you're working on, you're just melting an alloy onto it to seal it. Comprende? Okay. Now, we went over low side here. Let's talk about occupancy. Occupancy is what you always have to put on a permit. How is the building going to be used? What is its purpose? Is it R? Is it for residential or even hotels? Are people going to be sleeping there? Do we need to have extra smoke detection and carbon monoxide detection because of that? And the code addresses that if people are sleeping there. Is it E? Is it educational? Is this a school? What are some things we have to deal with that? So there's specific codes, and the occupancy is how the building is intended to be used based on the code. The pressure design or design pressure is the maximum pressure that's allowed to be on the system, okay? So what they're saying when you have, let's say, an air conditioning and refrigeration system is maybe the evaporator, it'll say test pressure or design pressure on the nameplate. It might say something like 150 low side, the blue is low side, 300 high side. That has nothing to do with the pressures on the gauge manifold or anything like that. That has to do with, they factory tested up to that point. They don't want you to exceed those pressures. So even if you're doing a pressure test with nitrogen or whatever on your system, don't exceed those pressures. That's what that means. Okay? Now, reclaimed refrigerant. Reclaimed refrigerant is when you remove refrigerant from a system and then you send it out and they bring it back to a new standard. That is reclaimed refrigerant. Okay? A unit heater is a heater that's in the occupied space for non-residential heating. Okay? And it usually hangs from the ceiling. So it's right there in the space. Cosmetically, people don't always like it. You'll see it a lot in garages and gymnasiums. I just saw one hanging from the ceiling in Home Depot right as you're going from the actual inside Home Depot to kind of the outside garden section. I just noticed a unit heater hanging from the ceiling to provide that extra spot cooling because it could get very cold right there where the doors open and close. Okay, so a unit heater, non-residential heating in the space itself. And then we have a pressure relief valve, a type of valve, pressure relief valve. A pressure relief valve is a valve that will relieve pressure for safety. It's sort of like the last defense so that we don't have an explosion or something like that. And it's used all over the place. Hot water heaters have pressure relief valves, which can relieve if even the temperature or pressure gets too high. Boilers have pressure relief valves so that we won't create a steam bomb. It will relieve pressure. Even large air conditioning or refrigeration systems have pressure relief valves. Okay, so this is a way of safely getting rid of the excess pressure without the pressure just totally building up in a fire or something like that with refrigerant and causing a big issue. Okay, so pressure relief valve. So that concludes my lecture on definitions based on the Uniform Mechanical Code. Thank you.